Okay, so now we can look at an example of something I've been mentioning, which is how total revenue is related to the elasticity of demand. Now you can do your own check to see if you can use the midpoint formula for demand. And if you did, for each one of these demand curves, given these points, 11 and 95, 9 and 105, you would find that the elasticity of demand for this region right here is going to be, I guess I got a little fat pen on, don't I? Elasticity of demand is equal to 1/2. There we go. 1/2 is less than 1, so this would be characterized as inelastic. So the demand curve on the left is inelastic. And then if you do the calculation for the one on the right, the elasticity of demand would work out to 3/2. 3/2 is greater than 1, so the picture on the right is an elastic demand curve. There is one thing I forgot to mention with the calculation of elasticity. I made a point of telling you to keep things straight, the Q1, P1, Q2, P2, so that you would maintain the negative. And then I forgot to tell you that when you do a calculation, when I do this calculation, it actually calculates out to -1/2, and it actually calculates out to -3/2. And we do take the absolute value of it and just drop the negative. So we can talk about it being 1/2 and 3/2. And the reason is the negative is implied as soon as I mention that this is the price elasticity of demand, okay? So do your calculation, get your negative, take the absolute value, now you've dropped the negative, and then you start comparing it. Is it greater than 1, less than 1? That sort of thing. Okay. So back to this picture, we have an inelastic demand on the left and an elastic demand on the right. Let's look at this as far as total revenue goes. So the story on this one is we're going to start with a price of $9 and we're looking at raising the price to 11 and we're wondering what that does to our revenue. So on the left-hand side, our inelastic demand, our revenue when it was $9 is the $9 times 95, which, did I do that right? Oops, sorry. $9 times the 105. See how 9 goes with 105. 9 times 105, which equals $945. If we were to raise our price, and this was our demand curve, now the $11 is associated with 95. So it's 9 times 105 to get 945, and 11 times 95 to get 1,045. All right, let's do the right-hand side. Again, starting at $9, which is associated with 115, we are going to get a revenue of price times quantity, 1,035. If we start with $11, or if we raise our price $11, we will now sell 85 units, and that is a revenue of $935. So I worked these out to show you then that with an inelastic demand curve, the one on the left-hand side, we see revenue grows as our price is raised, okay? Revenue is, total revenue is price times quantity. So when we have the price going up, so this side is going up, we know quantity is going to go down, law of demand, but how much does it go down? And when it's an inelastic demand curve, it's saying that the responsiveness of the quantity demanded, the amount it changes is less than the price. So for any 1% increase in price, you're only going to get a 0.5% decrease in quantity demanded. So you get your total revenue increasing. On the elastic demand, which means you have a very responsive change in demand when you raise the price or lower it, but in this case we're looking at raising the price. So when I raise the price, I get a big drop in the quantity demanded. All right, another way to see this is to look at it graphically. When I am charging $9, let's look at the left-hand side, $9 and selling 105, this rectangle I'm outlining is your total revenue. And when I'm charging $11 and selling 95 units, this rectangle is your revenue. So at the old price, how can I say this? If you look at the two rectangles, we are losing this amount, and we are gaining this amount. And what we know then, since the revenue does in fact increase, is that the amount we lose is smaller than the amount we're gaining. And so we end up with a net positive. Over here on the right-hand side with the elastic demand, it's the same thing. We are looking at revenue of 9 times 115, so it's this rectangle, or 11 times 85, so it's this rectangle. So we are losing all of that and gaining this. And so since we can do the calculation and see that we actually have a net loss in revenue, we know that we're losing more than we're gaining. So again, then, the point of this is if you understand your demand curve, if you maybe you're in a marketing class and you've estimated your demand curve and you're trying to make decisions about what would happen if I put something on sale, that's the opposite of what we've been doing here. But if I put something on sale, I'm talking about lowering a price. And when I lower a price, I want to do that if I have an elastic demand curve, because then I'm going to be moving to a higher total revenue. And that makes sense. People are very responsive to a price change, and so I lower it and I get a very big quantity response. So if I'm looking at doing a sale, I would rather have a elastic demand than an inelastic. And then in the case we're looking at here where we're raising the price, we see that we're going to essentially be punished less by a drop in quantity demanded with the inelastic demand, because I actually have my revenue go up when I raise my price if I have an inelastic product.